Okay, so for part A, this is something that we've been doing, right? We've been learning how to balance these precipitation reactions. It's not too bad. I'm gonna go through this part a little bit quickly since you should be pretty familiar with it. But what you want to do is you want to take a look at each chemical and you want to figure out what ions come out of it, right? What the positive and what the negative ones are. So let's start with the first one, PbCl2. We're going to take a look at our solubility table. So if we look at our solubility table, what's the positive ion that comes out of that chemical? PB. Yeah, Pb. Okay, and it's 2 plus. Exactly. And then obviously the other one is Cl because it's PbCl2. So we got Pb2 plus and Cl minus. Right? Everybody good with that? Oops, wrong page. Okay, so this chemical turns into Pb2 plus. And this turns into Cl minus. Okay, everybody good with that? That part should be pretty easy now. Okay, let's go to the next one. We got Na2S. So if we take a look at the solubility table, what's the positive ion that comes out of Na2S? Na. Yeah, Na right here, Na plus. And the other one is obviously going to be S, right? 2 minus. Okay, so from this chemical, the two ions that come out are Na plus and S2 minus. All right. So far, so good? All right. Okay, so what we're going to do now is we're going to write the other side of the equation. We got to figure out what chemicals they make. Now, we said that it's double replacement. So we take the positive of one of them and we combine it with the negative of the other one. And we want to make sure the positive and negative energy is balanced out. So I'm going to just write them next to each other for now. So Pb and S. Okay, so if you notice, Pb is positive 2 and S is negative 2, right? So if we put them together, does the energy balance out? Yes, it does. It's plus 2, minus 2, so it balances. Good. Okay, let's go to the second chemical. Now what we're going to do is we're going to take the positive of the other one with the negative of the other one. So we're going to combine Na plus and Cl minus. So if we put those together, does the positive and negative energy balance out? Yeah, it's plus 1 and minus 1. So there you go. Excuse me. You wrote the products. All you got to do is balance the positive and negative energy. Okay. All righty. Any questions so far? Okay. Sorry. What I want you guys to do now is I want you guys to take about maybe a minute and I want you to look at the person next to you and figure out if they dissolve in water or not. So I want you guys to write the parentheses and figure out if it's going to be AQ. So if you guys remember, if it's soluble, if it dissolves in water, we're going to write AQ in the parentheses. And if it is insoluble, it does not dissolve in the water. So we're going to write S in the parentheses for solid. So I'll give you guys about a minute to fill in the parentheses. And then after that, we got to balance it. So I'll give you a minute to do that and then we'll do the balancing. Okay, so if you guys take a look at PBS, the channel, okay, we're going to line up PB and S. Does PBS dissolve in water or not? It does not dissolve in water because PB, S is insoluble. So what we're going to do is we are going to write solid. We're going to write S inside of the parentheses. Okay? All right, what about NaCl? Does NaCl dissolve in water? Yes, so we're going to write AQ. All right, so there you go. That's going to be the parentheses. Any questions about that part right there? Okay, let's go to the let's finish up this part. So what we got to do now is we got to balance the equation. We got to make sure that we have the same number of everything on both sides. So what we're going to do is underneath the equation, we're going to make a quick table. We're going to write all the elements. So Pb, Cl, Na, and S. And we're just going to count how many are on the left side and how many are on the right side. And we just got to make sure it balances out. Does it look familiar, guys? I remember we did this like back in like November. Okay, so yeah, we'll be going over that again. Okay, so let's just count the elements. So if you take a look on the left side of the arrow right here, how many PBs do you see on the left side? Yeah, just one. Okay, we see PB. There's no number next to it, so we got one. Okay, let's go to the next one. CL. How many CLs are on the left side of the arrow? 2, yeah. There's a 2 behind CL, so that means you have 2 CLs. So we got 2. How many NAs do you see on the left side? 2. Okay, and how many S's? 1. Good. All right. I'll give you guys 30 seconds to do the right side. So fill out the right side. How many P, Cl, NaS? Should be pretty easy. So I'll give you 30 seconds to do the right side, and then we'll go over it. Yeah, super easy, right? It's just 1, 1, 1, 1. Okay, so 1, 1, 1, 1. Okay, so what we want to do, if you guys remember for balancing, is we want to add to the side that has less. Okay, so if we look at PB is good to go, right? It's 1 and 1. But if you take a look at CL, which side has less CL, left side or right side? Yeah, the right side has less. So we need to add to the right side. Now, unfortunately, you can't just do this. You can't just write CL because then it's a different equation, right? So we got to add the entire thing. So we have to add NaCl. Okay, and that's going to change up our numbers. So if we take a look at this, if we add NaCl, how many CLs do we have on the right side now? 2. And how many NAs do we have now? 2. Okay, 1, 2. All right. And then are we balanced? Yeah, we're good to go. So that's it. So all we got to do now is, if you look at NaCl, we wrote NaCl 2 times, right? So we just put a 2 right here, and that's it. We're all balanced and good to go. That's going to be it. Okay, so this one was relatively an easy one, and I'll do my best to try to give you guys easier balancing ones because you're already doing so much stuff for these problems. But just to let you guys know, for this unit, the numbers in the front right here, if you guys want to jot it down somewhere in your notes, I promise it will never go higher than 3. Okay, I promise. And if it does, then I will cancel that assignment and you'll just get 100 for it, okay? I promise it'll be 3. But, you know, the right answer will never be bigger than 3, obviously. Some of you guys are going to just put like 5 or something just to get out of it, but... Okay, everybody good with the balancing? Okay, let's move on to the next part. The next part, again, this is kind of review. It's stuff that we've been doing. We're going to draw a picture of the system. So we got a box on the left, a box on the right. So I'll give you guys a second to draw those if you guys have not already. But what we're going to do is we're basically going to just pretend that these are the containers that we have. And in your upcoming lab, that's what we're going to be doing. We're going to be actually mixing these compounds and producing solids and stuff. And so what we got to do is just write down what form they exist in. So if we take a look at PbCl2, this is the first chemical we have on the left side. Does this dissolve in water? Yes, it's aqueous. So we're going to write that it exists like this. It exists as Pb2 plus and Cl minus. So they break up when they're inside of water. Yeah, so if they're AQ in the picture, you break them up. Okay, because they dissolve in water. So the ions, they separate and they kind of just float around on their own. Okay, let's go to Na2S. Does this guy dissolve in water? Yes. So we're going to write the ions. So S2 minus and Na plus. And I know there's 2 NAs. So if you wanted to really do this, you can. But if you only have just the 1 Na, that's totally fine too. All you got to do is identify the ions. If you want to write it twice just for yourself, you can, but it's not required. Okay, let's go to the right side. And right side, I'll go through kind of quickly. If you take a look at PBS, this guy does not dissolve in water, right? So we have to write the equation like this on the bottom, PBS, and we just draw a little mound to show that, you know, it's a solid. Solids sink when they're inside of water. And then last but not least, we have Na plus and Cl minus floating around because it is aqueous. Okay. All right, so far so good? All righty. So precipitates are basically the chemicals that have the, you know, parentheses S next to it. So our precipitate is obviously PBS. And so we got to write the name of the precipitate. Okay, so what we're going to do is we're going to look at the periodic table to figure out the name of these elements. So first, we have PB. So if we take a look at the periodic table, which element is PB? If we take a look at the periodic table, what's the name for PB? Yeah, lead, right here. Kind of at the bottom right-ish, number 82, it's lead. Okay, so we're going to write lead. Okay, so PB is lead. Okay, now lead is positive 2, right? So we're going to put a parentheses 2 behind it. Okay, and then the second one, S, if you look on the periodic table, it is sulfur. Okay, but if the negative one comes from the periodic table, do you guys remember what you have to do to it? Yeah, IDE. So it's going to be sulfide. Okay, now if you write like sulfuride or something like that, or sulfide, I'm okay with that because the rules for changing the ending is a little convoluted. But just make sure that you have IDE at the end. Okay, but this is gonna be sulfide. All right, and there you go. That's kind of the review. I know that was a long review of all the stuff we've been doing basically this whole semester. Now what we're going to do is we're going to take this and we're going to do stoichiometry with it. Okay, yay. I know. You guys missed stoichiometry? No? I did. Yeah, but I mean, I love math, as you can tell. Ah, bless you. Ah, bless you. Okay, guys. Anybody still copying this down? Okay, I'll give you guys a couple seconds to copy it down. Make sure you guys have it handy because we will need this information as we do part D, where we do the stoich. But I'm gonna go through it step by step with you. Okay, so whenever you have a stoichiometry problem, the first thing you want to do is you want to balance the equation, but luckily we already did that, so we can move on from there. So the second thing you want to do is you want to figure out what the starting chemical is. So you guys might want to jot this down. And you want to figure out what the ending chemical is. Kind of sounds familiar, right? You want to identify what chemical you start with and what chemical you're trying to end with. This is going to help you set up your stoichiometry. Okay, so let's take a look at the question. And then basically we're trying to figure out what chemical we have the numbers for and what chemical we want to end up with according to the question. So yes. This one, 4. We're doing 1, so you'll have 3 on this one. Yeah, and if you guys need more time, I'll give you guys another class where you work on it. I know these are like really long. Okay. All right, so it says suppose that you react 1,000 milliliters of a 0.45 molarity PbCl solution with excess Na2S. So okay, I know that's a lot of stuff. But let's just stop for a second. Okay. Yeah. No, if you guys remember, if you see that word excess about a chemical, do you guys remember what that means? Yeah, you got so much of it, we don't need to care about this guy. Sorry. Okay, if you have excess Na2S, you have so much of this, you don't need to worry about it. So if you want, you can kind of just put a little X through it just to show, hey, we don't need to worry about this chemical anymore. Okay, it's really just there for the balancing. All right, now if you take a look at the numbers, there's 2 numbers, 1,000 milliliters and 0.45 molarity. What chemical are these 2 numbers referring to? Yeah, PbCl2, right? It's 1,000 milliliters of a 0.45 molarity PbCl2 solution. So the chemical that we're starting with, the one that we have numbers for, is going to be about PbCl2. Okay? So I know this can get a little bit tricky depending on how comfortable you are reading and understanding the questions. But just remember, whatever chemical the number's talking about, that's your starting chemical, okay? All right. Next, it says, what is the theoretical yield in grams of the solid product produced? Okay, so if we take a look at all the chemicals that are involved, what's the only chemical that's a solid? Yeah, PbS, right? This is the one that had a parentheses S. So that means the chemical we are looking for is PbS. Okay, does that part make sense? How we figured out the starting and the ending. Basically, the starting, if you want to jot this down just kind of as a reference, the starting chemicals are the ones that you have numbers for. And then for this unit, I'll just kind of tell you, the ending is usually just going to be your solid, whatever is parentheses S. It's kind of an easy way to think about it. Alrighty, let's start solving the problem now. All right, now if you guys take a look, the numbers that we start with are 1,000 milliliters and 0.45 molarity. Now, we know that we need to use this equation right here to solve the problem, right? Okay, now if you take a look at this equation, do you guys see milliliters or molarity here? No, right? You just see grams and moles. So what that means is we need to use these numbers to find out either grams or moles. Now, I want you guys to write this equation down because this is what we'll be using. If you guys remember from like December, God bless you. The equation that we use is molarity is moles divided by liters. You guys remember this? Yeah. Maybe some trauma. Okay, moles divided by liters. And so what we're going to be doing is we're going to be using this equation to figure out moles so we can put it into this equation right here. Okay, does that make sense? Okay, so let's just plug in our numbers and see where we go. So if you take a look at capital M right here, do we have molarity, a number for molarity? Yes, right here, 0.45. So we can just plug in 0.45 right here. Okay, now we want to find moles, so we're going to leave that there, and then we got to do the number on the bottom. Now, if you guys notice, the number that we have is milliliters, but we need to put in liters, right? So what we're going to do is we're going to divide by 1,000, and that's going to give us 1 liter. So whenever you want to turn milliliters into liters, just divide it by 1,000. So on the bottom, we're just going to put 1. So that's where we get the numbers for this equation right here. It's a really long problem, right? A lot of steps. All right, now what we want to do is we want to make sure that moles is alone. So we're going to multiply by the bottom on both sides, so multiply by 1. Okay, so our answer is just going to be, so these cancel out. Moles is going to be 1 times 0.45, which is going to be 0.45. And just remember, this is our starting chemical, so we're still talking about PbCl2. Okay, so I'll pause right there for now. Okay, everybody good so far? Okay. So what we got to do now is we need to take this number and put it into this fraction. Now, if you guys look, remember how when we did stoichiometry before, we always started with grams, right? But if you take a look at the problem that we have now, do we have grams anywhere? No. Okay, so this is actually going to make it a little bit easier for you because what we can do is we can actually skip this first step and we can actually just start here on the second step. And we're going to just put in our number on the top of the second fraction, 0.45 moles of PbCl2. Okay, and then the chemical we want to find is PbS. So on the tops of the remaining fractions, we can put PbS. Okay, so we can just kind of autofill from there. Okay, we take 0.45 moles of PbCl2, put it right here, and then we put PbS on the remaining two. Okay. Okay, so we're almost ready to finish. So since we want to get rid of PbCl2, we're going to put PbCl2 on the bottom. And then on this fraction right here, the mole and mole fraction, the numbers are going to come from the balanced equation. Okay, so all we got to do is look at the equation, figure out what numbers are in front of these chemicals, and just put it on the fraction. Okay, hopefully this looks a little bit familiar now. Okay, so if we look at PbS in the equation, what number is in front of PbS? Yeah, it's 1 because it's blank. So we put a 1 next to PbS. What number is in front of PbCl2? 1. So we put a 1 on the bottom. All right. And then the last fraction right here, on the bottom, we're going to put PbS because we want to get rid of moles of PbS. And then the numbers for this one are going to come from the molar mass. Okay, so we go on the periodic table, look at the number on the bottom, add them up, and that's what we'll get. So we'll do this one together. So PbS has 1 Pb and 1 S, right? So the molar mass is really easy. So if we take a look at the periodic table, what's the molar mass of just Pb? Yeah, it's going to be 207.2. And then it's made up of Pb and S. So if you take a look at S, what's the molar mass of S? Yeah, so we add 32.07. So the molar mass is 239.27. Okay, so we're going to take it back right here. And that's what we're going to write for our molar mass. Okay, 239.27. So we're going to write 239.27 in 1 mole. Okay, and the answer is we just added up Pb and S. That's where we got those numbers from. We just added those two up. That was 207 plus 32.17. And that's how we got 239. Alrighty, guys. All we got to do now is plug it into our calculator, and we are finally done. And I promise that's the end. Okay, I know that was insanely long. Okay. So for the math part, if you guys want to write this rule down just kind of as a reminder, you can. But all the numbers on the top, you're going to multiply. All the numbers on the bottom, you're going to divide. If you guys remember this, you don't have to write this down. And then the important thing is you just ignore the ones. Okay, if there's a 1, you just ignore it. But all the numbers on top, you multiply. All the numbers on the bottom, you divide, okay? So we're going to do 0.45, which is our starting number right here. We're going to ignore the ones. We're going to ignore the 1. 239 is on the top, right? So what should we do with that number? Yeah, multiply. So 239.27. And our final answer is this right here, and then we're all done. Okay, 107.67. I'm going to round it, and it's going to be grams of PBS. And that is it. And this is pretty much all we're going to be doing until like mid-March when we take the test. So your test for this will be probably like the 2nd or 3rd week of March. I have to look at the exact date. But you got basically like 2-3 weeks to really understand this. We're going to do a lab on it just to kind of help you guys understand it a bit more. And then we'll take the exam mid-March. Okay. Alrighty. So same thing as usual. I recorded this, so this recording will be there. If you ever need a backup, review your information, I'm here if you guys have any questions. I got answer key if you need to check your answers. And I'll give you guys the rest of the class period to work on either the previous assignment, which is kind of the same problems, and today's assignment if you got time. Okay. All right. So take the rest of the class period to work on that. Let me know if you have any questions.